In order for you to complete an equation, you have to use your ion sheet. If you don't know these ions by heart by now, you may use your ion sheet. That is fine. I'm allowing you to do it, but you need to be able to do so very quickly because this is a multi-step process. So you will be given an equation, and your task will be to write the molecular equation and that ionic equation. Now, be aware that this can be given to you in the chemical formula. The chemical formulas may be provided like here, or you may be given the names and you have to write the formulas and of course complete the reaction. So very well, we have right here calcium chloride and potassium carbonate. And we need to be able to go through the process of writing the molecular equation, basically this equation here that we did above, and of course, eventually reach the net ionic equation where the chemistry is occurring, which is only includes a precipitate and the ions that form the precipitate. So that is it. So let's begin. In order for you to do this, you need to start by writing the ions right here. So we have calcium, that's a +2. Calcium, and it's a +2 charge. We may look at it really quick. Right here. And while we're here, we have also sodium, so it's a +1. And you have Cl, chloride. Here it is, Cl-. And of course, you have carbonate. Carbonate is right here, CO3 - 2, CO3 - 2. So we have Cl, Ca plus, we have plus the Cl minus, we have Na plus, and we have CO3 - 2. In a double displacement or replacement reaction, the first cation goes with the second anion. So in this case, Ca will go with CO3. Now, what are the charges? They're equal, so they cancel out. So I'm going to write CaCO3. Now, some of you may wonder, okay, what happened to that other Cl? Well, you have a choice. You can add it. So I'm going to include it. There's 2 Cls right here. And of course, there's 2 sodium ions. So of course, these go together. So they cancel out each. So you have 2 NaCl, 2 NaCl. Now you should know by now why we put the Na first. It's cation, then anion. Here it is, 2 NaCl. That 2 means I have 2 sodium ions and 2 chloride ions. So here's your molecular equation. I already did that basically here on the top. So I'm going to transfer this down here. So CaCl2 plus Na2CO3, CaCO3 plus 2 NaCl. So it's already balanced for you, or you can use simple balancing procedures. Now, the next thing is we need to go and check our solubility sheet to determine which substances are soluble, and we give them the prefix or the subscript AQ, and which are precipitates. which is S. We give them S for solids. Now, I'm going to make it simple for you. Whatever you start with is always going to be soluble. So obviously right here, this is going to be AQ, Na2CO3. Nevertheless, you should verify them. Again, we use this table with multiple examples. But now let's go and find if either of these is soluble or insoluble. We actually did this one. So you can go back and verify right here. And you see that calcium carbonate was insoluble. And sodium chloride is soluble. So let's just check. Calcium carbonate, carbonate is right here. It's insoluble, and again, calcium is not one of these that make it soluble. Sodium chloride, you know, that's table salt. So be able to use this effectively. That's why I did multiple examples. So therefore, we have CaCO3 solid plus 2NaClAQ. Once again, this to the reader indicate that this is my precipitate. Right away, highlight or underline or write down precipitate. Let's use a different color here. PPT. Now, in the next step, what you need to do is you need to take what you had before, really take what you had before, and break the soluble compounds into their ions. So that's why if you do work at the beginning, then you don't have to do it again at the end, only maybe slightly more. So once again, we have to break these into ions. Ca plus 2, we put the AQ after it, has to apply. Now, you have a choice. You can list the Cls like this, and it may be too much work to list every single one, or we simply say 2 Cls. This is the same as saying 2 Cl minus. Either one is acceptable. Some students may like to see the numbers being written, but again, we're in chemistry, we should know what that 2 means. That coefficient indicates the number, how many of those ions you have. So you have 2 sodium ions, and of course, a carbonate ion. So again, these are the same thing, but in different forms, and that's absolutely fine. Now, it says here, leave the precipitate as a compound. It's insoluble. So you can't simply now break this into its ions. That defeats the whole purpose. A little bit of it dissociates, but not all of it. So then we just leave it untouched. We just simply copy this down because that's my precipitate. S plus, of course, the 2 sodiums. Or this right here, plus 2 NaCl. Very well. Now it says to you here, this is the most important step, is to cancel out the spectator ions. Those are the ions that do not form the precipitate. So what forms the precipitate is calcium, or our calcium and carbonate. These are the ones that form this right here. Look at it. Sodium and chloride are spectator ions. A spectator means it's looking, doing nothing, and that's their function, is that they're not doing anything. So in this case, my spectator ions are Cl and sodium. I cancel them out on each side. Na plus, I should have written there, Na plus. Once again, I'm going to write here on the side that the spectator ions, it's interesting here. Spectator ions are Cl minus and Na plus. These are my spectator ions. And all I have to do next is simply write down what's left over. So what's left over, if I got rid of these, is Ca plus 2, carbonate, that would make calcium carbonate, and that's a solid. You must include the states. You must include the states. And this is your net ionic equation. It's very, very straightforward. You just, again, have to practice with this. Now, let me just tell you one thing, that if you ever reverse this, and you will see this in Gen Chem 2, if I reverse this, I start with a precipitate and then I go this way. There's a name for this, and this is called a dissolving equation. So instead of a net ionic equation, this would be called, if you reverse it, a dissolving equation. Very well. Make sure you do this before we meet next time. Go over it, finish it, and then we'll check together.